Okay, today I just want us to do an introduction on a probability. Probability is all about the chances we are taking or the chances that are taken for something to occur in either of the favor of something or not in favor of something. What do we mean in that way, in favor of something or not in favor of something? For example, if we are having a bowl with two types of balls, the first ball it's a red color, and the second ball is a blue color. So found out that there are 5 red colors balls and also 3 red colored balls. So which means in other words, we are having 8 balls in total. And then if we're having 8 balls in total, let me just say 5 red balls and also 3. Remember, I'm just giving an example. 3 blue balls. Just an example. Now with these balls that we are having here, with the balls that we are having here, inside the bowl, there are 3 balls plus 5 balls. So in total, there are 8 balls. Now, me or you, we are in chance of picking any ball without looking inside. So what we do, or for example, the way in which if you used to see the Powerball or the lottery, when they play those things, they put the balls in numbers inside. Those balls are different. Number 1, number 2, number 3, up to however they are. And then the machine itself, it keeps on spinning those balls. And then after it spins those balls, they only want 6 balls or 5 balls. So they choose out of 56 balls or 58 balls or 59 balls or 10 balls. It's up to what are we talking about. So you can see how the machine just randomly pick any of the numbers. So what happening there, the chances of picking any number, that's where we comes in mathematics and say the probability of picking this number is this and that. Now let me come back to my example here. I'm having 8 balls inside the bowl, and inside the balls there are 3 blue balls and 5 red balls. And then out of those 8 balls, I have to choose 1 ball. And then after I choose 1 ball, I don't take it back, I take it out, which means when I choose 1 ball, after I choose 1 ball, I remain with 7 balls. After I choose another ball, I remain with 6 balls. After I choose another ball, I remain with 5 balls. Up to I'm remaining with the last ball, which is the only one I have to choose. But I don't know. My question is that I don't know which ball will I have to choose when I just pick up randomly inside the ball. Sorry, yes, inside the ball. So let's just do the probability of what are the chances of starting to pick the balls. And just know that the chances of picking something it's always equals to 1. Probability is always equals to 1. Meaning out of 1, the chance you can either do or not do. It's when we refer to as the probability is the 50% chance. So if I have to put my hand inside the bowl and pick 1 ball, it means I'm having 50% chance of picking and a 50% chance of not picking. But then out of these 8 balls, when I choose, for me choosing the red ball, I will start by saying all the total red balls inside the bowl, they are 5. But if the balls that are red, they are 5, all the total balls inside the bowl, they are not 5. The 5 is only the red balls. Then the total balls inside that I will pick, they are 8. So which means the chances of me picking a red ball at the first pick, it's 5/8. That is the first chance of picking the red ball, it's 5/8. And if I haven't picked any ball yet inside the bowl, and I have to choose, but then if I choose, and then I choose the blue ball, it means that the chances inside the bowl when I have to choose the blue ball, the balls are 8, but the blue balls are only 3. So it means I will pick any of them, which is 3 chances out of 8 that it can be the blue one. That is where the beginning it starts. It's from our more probability. So always when you add the 2 chances, the chances of having the red ball, picking it, or the chance of picking the blue ball, when I add the 2 chances, I'm having the probability, the chances or the possibilities that are 2. Possibility number 1 and possibility number 2. So out of these 2 possibilities, when I add those 2 possibilities, they are equals to 1. They are equals to 1. The chances of picking. So when you punch on a calculator, 5/8 plus 3/8, the answer it has to give you 1. If it's not 1, then it's not mathematics that I learned. That is a chance always. So now look at how many chances in favor of what? In favor of 5/8 is in favor of the red ball, while 3 out of 8 is in favor of what? Of the blue ball. The possibility they pick out of 8, the chances that are there, they are out of 8 possibilities. How many possibilities can you pick from? How many total things you are picking inside that bowl? There are 8. That's what we call the possibility. And that's why when we go back to the formula, it tells us what it is the favorable divided by the possibility. Favorable meaning what do you want to pick? Out of what? Possibilities out of what? If we are to see here, what do we get? Let me just open this file and see something here. And we will get to see. Okay, here we are. Yes, the same file I opened, I couldn't. Let me just explain it in the context that you can understand. Now, here they define probability as a formula, or they have probability as a formula, saying that probability is equal to the number of favorable outcomes. What do you want to achieve when you do what you do? Out of number of possible outcomes, what do you have from what you want to achieve? What do you have? Now, in my example, I want to pick a red ball. So red ball is favorable outcomes. Okay, when I mix the red ball, how many red balls are there in the bowl? There are 5. Divided by. Okay, number of possible outcomes. What are the outcomes that when you pick the ball inside the bowl is a red ball? How many balls are in there that you will pick from? There are blue balls, there are red balls. All in all, they gives me 8, because when I pick without looking, to pick randomly, I can just choose any ball. But if I am to choose the ball is red, it's 5 out of 8. So then if I was to choose and then the ball is blue, which means how many favorable, what is favorable outcome here? Favorable outcome is blue ball. So blue ball, how many blue balls are there? The number of blue balls, there are 3. Out of how many balls that are there inside? How many balls are there? There are 8 balls, which is the number of possible outcomes. From my example, this is what we mean. So there are always different different events that they can occur with conditions, but we will get to that. Now, the facts about the probability. The facts about the probability. Now, the facts about the probability, we are talking about the first one here, the probability of an event that cannot occur is 0. What do they mean? The probability of event that cannot occur is 0. Okay, which means, Warren, let me go back to my scenario so that we can understand. I am having 2 different balls, 3 blue balls and 5 red balls. I'm having 3 blue balls, and 5 red balls. Total balls inside the bowl, they are 8. Now the question can come, what is the chance or the probability of you picking a white ball from this bowl? Be careful there. Do we have white balls inside the bowl? The statement said, I'm having 5 red balls inside the bowl mixed with the 3 blue balls inside the bowls. All the balls inside the bowls, they are 8 balls. But the question says, give us the chance or the probability of picking the white ball. Now, do we have a white ball? The answer is no. So the probability of picking something or of an event not to occur, we cannot pick the white ball. It's an event that cannot occur, which means the probability is 0. Come back here, then it certifies what? This is the first fact. The probability of an event that cannot occur is 0. We cannot pick the white ball from the bowl. Why? Because the bowl is full of 8 balls, and out of the 8 balls, 3 are blue and 5 are red. That's what they mean when they say it becomes 0, okay? It's 0. Fact number 2, the probability of an event that is certain to occur. What do we mean certain to occur? It means it is possible. It is possible to occur. They say is what? Is 1. That is why I said that let me add the 2 chances. Add that 5 over 8 3 over 8. They have to give me 1. Even if when you punch on your calculator, there will be 1. These are the 2 chances. The first chance is the chance of picking the blue ball, which is 3 out of 8. The second chance is the chance of picking the red ball, which is 5 out of 8. But then this is chance number 1. Chance number 2 is to pick the blue ball, which is 3 out of 8. But then all of the chances that are available, when I add them, they must give me 1. This is what the statement means when they say that the probability of an event to occur is 1. They say certain to occur. So which means, yes, the probability of event, yeah, my bowl with 8 balls, 3 of them being blue, and 5 of them being red. It means we are now having 2 events. No longer 1 event, we are having 2 events. Event number 1 of red ball, event number 2 of blue ball. So which means the probability of the event to occur, we will now say all the events that are available, we plus them, they must give us 1. The event of having the red ball is 5 out of 8. Of having the blue ball is 3 out of 8. So this will give us what? Will give us 1. That's what I mean. The third statement. Every probability is a number between 0 and 1, inclusive. Which means, the number, it cannot be the whole number. If it's a whole number as 1 and or 0, remember, or 0, it cannot occur. As it is 1, all the events, when we add them, they are 1. So which means, let's go back to our example. The probability here is 5 out of 8. When you look 5 out of 8 in a form of a decimal or the commas, removing it from the fraction, you will get 0 comma something, 0 comma something, and a 0 comma something. It is not 0, it's more than 0, and it is not 1, it's less than 1. If we go to 3 out of 8, you will still get 0 comma something. And a 0 comma something is the number in between 0 and 1. That's what they mean. And they can never be negative. Number 4, the sum of the probabilities of all possible outcomes in an experiment is always 1. This is just, I have just demonstrated now here. When I was saying that I am having probability of being red and probability of being blue. When I add the 2 probabilities, it must give me 1. This is what I've been saying, and this is what is satisfied now by the statement. The last one, I also said it. A probability of 0.5, which is 1 over 2, or 50%. It means that the event is just likely to happen as not to occur. It means there's a 50 chance percent of occurring and also another 50 chance percent of not occurring. So it's halfway. It's either both way. It's either head or tail. So head or tail chances is half and half. Now the scale of probability, we have from 0 to 0.25 or 1/4. They say it's very unlikely to occur. The event is occurring, but it's very unlikely. How do we find, how so? If I am to choose, if I am to choose between the two events here, we are having event of having the red ball, which is this one, and the event of having the blue ball, which is this one. Now, when I convert the two numbers into decimal or into numbers with commas, I will receive, or I will see that 5 out of 3, sorry, 5 out of 8 is something like 0, 0, 0, 0, what? 0, is it 0.6? Something like 0.6, yes. 0.6 something. Number
0.625.
0.625, very good. So if we get 0.625 in a form of decimal, let's see where is this chance. So which means 0.2625, it's more than 0.5. So which means it's gonna be in between here, because when we convert 3 out of 4, we get something like 0.75. 0.75. And then our answer, which is 0.625, our 0.625 is going to be in between here. Now let's check out the probability of 3 out of 8 and put it in a decimal also and see how much we get. We will still get 0, something, which is somewhere like 0.3. 0.3 something, if I'm not wrong. So when we come back to 1/5, so 1/4, 1/4 in decimal also is 0.25. So which means 0.3 is more than 0.25. Yes, we are right on this one. So which means now, between the two chances of the red ball and the chances of the blue ball, which chance is more likely to occur? The question they can ask you, which one is more likely to occur? You will check the one that it's more than 0.5, which is more than 50% chance. So which means the probability or the chances of you picking a red ball, it's higher than the chances of you picking the blue ball when you go and pick inside there. That's what they mean. So it's more likely it's going to be in this manner. It's unlikely to occur. When you put your hand inside the bowl to pick up a ball, you are more likely to pick the red ball. Why so? Because the red balls are many and the blue balls are few. So the scale keep on going up and up and up. If it's somewhere like 0.75, it's more likely. If it's 0.9, 0.8, it's still more likely. Very, 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 very likely. So we be careful and we understand these principles before we can now do any further part. We have to understand this principle. Okay. Impossible event, the event will not occur at all. When they say it's impossible, event will not occur at all. I said that out of the bowl, there are the red balls and the blue balls. And then they ask you, what is the chance or probability of picking the white ball from the bowl? White ball is not there. So the event doesn't exist, cannot occur. It means it's impossible. The event will not occur. When the event will not occur, the probability is equals to 0. There we are, simply explained there. Now going further, the ways to describe the probability, the ways in which we describe the probability, which means they are the keywords that they will use on the statement. Remember, these are the basics from grade 7, grade 8, grade 9, just after grade 9, this syllabus I probability. Grade 10, grade 11, grade 12, it's more advanced. But we have to know these things before we can do anything further, because when in the advanced mode, we must start with the basics first. When they say certain, it means that the probability or the event itself is definitely going to happen. E.g., for example, the probability that the day after Monday is Tuesday is 1. Yes. Why? Because it's the only chance. It's the only chance that is given. A day after Monday is Tuesday, and also a day before Monday is Tuesday. Then tell us which one is right. So you will have to know. So here now the event is only one. There is one event, and when the event is one, it's more certain to apply, also to occur. That is why the probability is 1. Very certain is 1. Likely, the event will probably happen, but not definitely. Not definitely meaning it's not the only event occurring. It's not the only event occurring. Be careful there. It's not the only event occurring. There are other events also occurring. It's not only the event occurring. It's not the only event occurring. So which means there are more than one event occurring. If we find it in this manner, it's not the only event occurring if it's certain. So if it's likely. And then what about it's unlikely? On the unlikely part, I don't know what happens. The event will happen. Probably, sorry, but the event will happen, yes. Probably, might, or might not. So which means, sorry, yes, the event can happen, or it cannot happen, but the event is available. What do we mean? There are 5 balls that are red. There are 3 balls that are blue. Now I'm adding another ball, 1 ball which is white. So there are now 9 balls. So the event of choose, or the probability of choosing white ball, it's unlikely, sorry. It's unlikely to happen. Why? Because it's very, 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 very low. You have 0, 0,0, 0,0, 0,9. 0,9, 0,1, yes, 0,1. It's going to happen, but it's not promising. When you choose, you can choose more than 5 times without choosing it. But for it to happen, yes, it will happen at the end if you are choosing more. Just 1/9. The last one, impossible. I've explained it. The event is definitely not going to happen. If now there are 8 balls, out of the 8 balls, there are 3 blue balls, there are 5 red balls. They're asking you, what's the probability of picking the white ball? Even though you see, you can see, and you know that there are no white balls. Then the probability is 0. It's impossible. That's what they mean. So the next thing, we have to express probability in any of the 3 ways. But the most way that we focus on, or that works for us, is the way of the decimal. Decimal, like this one. And also, we can write it in a form of fraction. So in most cases, in examination, they give you the decimal, which means what they give you numbers in commas. So when you work with the fraction, you can convert them. And when you convert them, don't forget that the instruction in mathematics that the answer must be in, if it's in decimal place, leave it to the 2 decimal places. Leave it to 2 decimal place. Nothing else. So in percentage, we can convert percentage to decimal. We can also convert percentage to fractions. I think my introduction is making sense. Okay, let's see the types of probabilities. The types of probabilities. The first probability is relative frequency, which is experimental and also theoretical. The second type of probability, it's okay. Oh, the theoretical probability, yes, and also the relative frequency probability. What do they refer to when they say theoretical probability? The number of favorable outcomes and then possible outcomes, which is the example that I've just given, like saying that we are having 8 balls. Out of 8 balls, 3 are red, so are blue, and 5 are red. That's theoretical, but the probability is estimated. So that is estimated, is calculated after performing a very large number of trials. So which means we are going to pick 8 times, checking what out of all the pickings, how many times did we pick the red, how many times did we pick the blue, and then we do the survey. Afterwards, we check. How do we do the survey? You pick, okay, let's say we are having 10 people, and then out of the 10 people, they are to pick out of the 8 balls. Whoever picks a ball, we record and take the ball back. So I pick the first ball, they record it's red, so 1 red. They pick again, they record the ball, or nice color is it. They pick until all the 10 people have picked. Then after they analyze, or how many people picked the red balls? If they are 5, so if they are 6 or 7 or 8 or 9 or 10, how many people picked the blue ball? They also check, so they convert. So it's more likely to say people who will pick the red balls will be more than the one who can pick the blue ball. Or the blue ball at all, it might not be picked, even though it is there. Why? Because there are very few compared to the other one. That's the theoretical one. Now the relative frequency probability, this one. They say the formula is what? Number of times the event happens. And then the total number of trials in an experiment. What do they mean when they say the number of times and the trial happens? So if we are then going to pick in the bowl, so in the bowl that has 8 balls, out of the 8 balls are 5 red and 3 blue. We will see. We have to now test and also check. How many times are we going to pick? What do we mean? How many times are we going to pick? Let's assume again we are still 10. Now we are going to pick. When we pick, we want to check how many times are we going to pick. And when we pick, the event says that you pick a ball and either return it or not. When we return it, it's something else, we will come to it. When we don't return it, it's something else, we will come to it. But then let's check how many people will pick. 10 people will pick. So if 10 people will pick, then it means we will have now the information of 10 people. The frequency now of how many times they picked or how many times the chances occurred, 10 times. So what do? We pick, the first one pick and record, second one pick and record, third one pick and record, up to that 10 after they are done. So if we check how many balls were there and how many people picked, then that's how we come back and do our probability. So we check how many picked and how many how many balls they picked, which are those balls that they picked, recorded aside, and then how many times they picked. So this is what we do mostly in grade 12 and grade 11. The number of times the event happens, total number of trials in the experiment.
So I can see what you're writing.
I'm not writing. I'm highlighting with the red circle. If you can see, can you see the red circle?
Yeah.
Yeah, I'm not writing, I'm using it to point where I am reading.
Okay.
Okay, there's a small activity here. I won't answer it. We'll just look at the questions that they can stimulate your brain according to this. The first question says, write down how you can calculate the theoretical probability. They automatically look for this formula as it is. Number of favorable outcomes divided by number of possible outcomes. Number 2, write down how you can calculate the relative frequency property. So the probability, the number of times the event happens divided by the total number of trials in experiment. That's what they want. Number 2, number 3, but briefly define what the term probability is. There is a definition on it. The fourth one, define the sample space. What do they refer to when they say the sample space? You also figure out what it is. And then the fifth one, they say, what do we mean by impossible event? We also explained what is impossible event. So these are the type of questions in grade 11 and 12. They won't ask you this. They can only ask you mostly grade 8, 9, and 10. Also, only if grade 9, they still have this in their syllabus or in their curriculum. But I doubt this CAPS doesn't have probability. So they can ask you this kind of questions in grade 10. Let's see what kind of question can they ask you in grade 11 and 12. Okay, let me just find an example here. Okay. So this example comes from grade 9 book. You can check here. It says Clever. Clever is the name of the book, the grade 9. So you can see what the basics comes from far. So we have to figure out the basics. Okay, let me just see one question. Remember, here we're not answering. We just look how they structure the question. Now, we are given an example saying that a bag contains 5 red balls. Okay, first 5 red balls. Event number 1, red ball given number 1, which means whatever we will do with the red balls, it will be event number 1. 6 black balls and also 3 yellow balls with what? And 6 purple balls. So how many balls are here? When you check, there are 5 plus 6, which is 11 plus 3, which is 14 plus 6, which are 20. So there are 20 balls inside this container, inside this bag. Now they say a ball is taken, they will always give you this statement. A ball is taken out of the bag, which means what happens when the ball is taken out of the bag? Then the color is noted down. They record which bag which ball did you take out of the bag? If it's red, if it's blue, if it's black, if it's yellow. Sorry, red, black, blue, or yellow. They write it down, they note it. And then the ball is replaced. What do they mean? The ball is replaced. They put it back where they took it. They returned it. Then this is done 100 times. This is a frequency thing. It is done 100 times. Then the following frequency table is completed. Okay, let's see then. Here are the outcomes. What do they mean, the outcomes? It means after they have picked out of one bag for 100 times, they were counting. So they figure out the counting of the red balls, it was 24 times. The counting of the black balls, it was 30 times. The counting of the yellow ball, it was 12 times. The counting of the purple balls, it was 36 times. So when you add all of these frequencies, they give us total of 100. they are 100 times. So when they pick in the first time, second time, third time, fourth time, so they figure out all the balls that were counted 24, they were red. 30, black. 12, yellow. 34, they were purple. Then the question they can ask you, Goring, calculate the theoretical probability of a purple ball being removed from the back. Calculate the theoretical probability of the purple ball being removed. Calculate the theoretical. So which means on the theoretical, like I said, that how many times is it that is occurring? The one of we were saying that it was what is it? It was the frequency. The frequency, it was the question of this, it was this formula. We are using this formula. This is the relative frequency of the probability on it happening. So which means we are going to have how many times did they pick? They picked 20, is it 20? No, it's not 20 times. They picked the purple ball. What is the purple ball? Purple ball, purple ball, purple ball. Purple ball, they picked 34 times. 34 times, 34 times, 34 times. Out of how many trials? Out of 100 trials. This is the theory. Sorry, this is the relative. Okay, now let's do the theoretical. The theoretical one, the theoretical formula says that the number of favorable outcomes. What are the favorable outcomes? Are the purple balls. Favorable outcomes are the purple balls. So let's go back to our, what is it? Our statement and see how many purple balls are there. How many purple balls are here? There are 6 purple balls according to the given. There are 6 purple balls. So which means on our theoretical, we're going to have 6 purple balls as the favorite outcomes divided by the number of possible outcomes. How many times did the purple ball been picked? How many times did the purple ball been picked? How many times did the purple ball been picked? We cannot come to the frequency. But then the purple ball that are 6, how many balls did they picked from? Or how many balls are there if we are having 6 purple balls? How many balls are there? They are 5, they are plus 6, they are plus 3, they are plus 6, which means we are having the 20 balls inside the container, the bag container. So which means, Warren, these 6 balls now are favorable in the possibility of all the balls being 20. So which means the answer in a theoretical probability is 6 out of 20. So you see the two things are different. When they say in the frequency, when they say in the theoretical. So in theoretical, you look how many original are there that they can pick from, and then how many times they were picked. Right. So out of how many total are there to pick from? How many originals are there to pick about, and how many in total are there to pick from? There are 6 original purple balls, and there are 20 balls inside the container. It has nothing to do with the frequency. Yes, I see a hand up.
No, now I figure out what I was about to ask. It is fine.
Okay. Okay, the next question. They say calculate the relative frequency of a ball taken from the back being purple, which is experimental. Experimental. It's here. We have done it. Which they are 34 times, or 34 chances out of the 100 that they picked the purple ball. So this, it is our answer. This, it is our answer. They picked the purple balls 34 times. when they were picking 100 times. So these are just sample questions that you can refresh your mind to understand, because when going further, we go deep into details. The last question I want to talk about is question 1.5. 1.5, it says that calculate the experimental probability of red, black, or yellow balls. Experimental, remember experimental, what are we talking about? Experimental, we're talking about the relative frequency. Relative frequency. Experimental, this is experimental. Relative frequency. So which means we are going to talk about this table. So the probability of picking what? Experimental probability of picking red is going to be 2 out of 24 out of 100, 30 out of 100, 12 out of 100, 34 out of 100. And then they say add this probability together, and what is your answer? When you add 24 out of 100 plus 30 out of 100 plus 12 out of 100 plus 34 out of 100, you must get 1. And yes, it will give you 1. So you see, they are running around with our minds just to understand. Are we clear on that one? Okay, if we're clear, let's go to the next lesson. Business of the day.
Sorry, sir, are you saving this video?
Yes.
Okay.
Business of the day. When we work with different types of events, now we come to the events. It is usual to make use of probability rule, which means they are the rules of probabilities that we talk about. The one of the theoretical and experimental, they are the types of probabilities that they can give you in these events. So let's see. The first rule is given, or the rule of probability is given, that probability of A or B is equals to, formula. This is a formula. Probability of either being A or B is equals to probability of A plus probability of B minus probability of A multiplied by probability of B. Probability and again, and 3% multiplied by. So this is the master formula. Master formula. There will be events in which that you must understand what should be 0, what should not be 0. Please, the information comes from the statement. The first one is when the probability, so when the event is dependent. What does it depend on? But this is when one event is dependent on the outcome of the other. For example, event A has an effort on the outcomes of event B. I will give you more examples on the next session so that we can understand these two. For other one to occur, the other one has to occur. What does it do? The next one. Like for example, when we, okay, let me talk about the, what is it? The floor tiles. Are you familiar with what I'm talking about? The floor tiles inside the room. So let's say that the floor tiles inside the room, they are 40. When they count the floor tiles inside the room, they are 40. Am I clear on that one? The floor tiles are 40 inside the room. And then if the tiles occupy the space, the probability of them occupying the space is 1. which means there is no space inside the room. So now we want to find the probability of having the space inside the room where there are no tiles. It's 0, which means there is no event of having the space inside the tiles, so inside the room. But then now the first event, the statement says that we remove the tile, the space of it. So we remove the tile from the room. So when we remove one tile out of the 40, remaining 39, what are we getting there? If there are now 39 tiles inside the room, but they're making the floor, okay? So the floor is filled with the tiles. When we count the tiles, there are 40. So I don't know what can I use here that it is very, 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 very. Okay, let me try to use something. What can I use? The shapes. Okay, let me use the rectangle. Let's go. I don't know if I'm trying to make sense. Okay. Okay, it can write. Here we are. Let me try to increase. Okay, this is the room. Now this room, it's made up of the, it's a floor. This is the floor. And then this floor, it has the tiles. Okay, let me try to put the tiles so that we can get a clear picture. Okay, 2, 4, 5. And I will have to put 8 this side. 1, 3, 4. Okay, 5. Okay, 6, 2, 4, 6. 1, 2, 3, 4, 5, 6, 7, 8. I have learned that 5 times 8 is 40. Okay, now these are the spaces of tiles. Please bear with me. These are the spaces of tiles. It means now the tiles, when the tiles are fitted, all the spaces are occupied. Now, if all the spaces are occupied, the probability of having the space inside this, the probability of having the space of no tile inside this room is 0. Why? Because all the spaces are filled with tiles. Now the event occurs that we remove one tile per event. Now when I remove one tile, it means I'm going to remove one tile from this. So when I highlight red, it means I remove the tile. And when I remove one tile, what is remaining is the space. So which means when the event of removing the tile occurs, the event of having the tile space appears. So which means it was depending on either we remove it or not. So there is no formula of calculating it. It just, okay, it's either 1 or 0. 1 or 0. 1 is the one that is appearing. 0 is the one that cannot occur when it doesn't work. That is why it's 1 or 0 more. Event A is either 1 or 0, neither B. Now we go to second part, independent one. But this is when the two events are independent of one another. So which means every event has to occur. They say event A has no effect on the outcome of event B. So the formula says that probability of A and B in working mathematically, it's probability of A multiplied by probability of B. So the same formula here is the same formula we will substitute here. Don't forget that. Second one, the probability when the event is inclusive. What do they say inclusive? This is when the probability are both, so of both A and B occurring is not equal to the 0. It's not equals to 0. This is when the probability of both event A and B occurring is not equal to 0, which means probability of A and B is not equals to 0. What do they mean? Probability of A plus probability of B. Probability of A or B is not equals to 0. So probability of A and B, remember, this is mathematical calculations. Probability of A and B, this whole thing here is equals to this. And it's not 0. So which means that this whole thing, as it goes with the arrow coming to this part, now this whole thing, we can work mathematically to find this as an independent part, meaning or as a formula, this thing P, A, and B is equals to. So we'll have to take this one to the other side of equation side and multiply everything by negative. Or we just say we take probability of A plus probability of B is minus probability of A or B is equals to probability of A and B. So the whole thing is not equals to 0. Probability of A and B going to be equals to probability of A plus probability of B minus probability of A or B. This is the same formula of original. Which original? This is the original formula we're talking about here. This is the original formula, please. So I just worked it out mathematically to get this one. To make the probability of A and B the subject of the formula. So the whole thing now is not equals to 0, which means it has a value. It has a reading value. And here it is. Let's give it this. And the last one, mutually exclusive. Mutually exclusive. This is when no element is common between the two elements or the two events. So which means probability of A and B is equals to 0. So which means now the whole system here, this thing, when you minus them probabilities, which means probability of A plus probability of B minus probability of A or B is equals to 0. These are the formulas. We're just working with the formulas now. And then Bona in examination, they are working with these weights. They give you these weights. When now what you must cram is this or no, is this, they are these formulas. Because in examination, they won't give you these formulas. They will give you these weights, mutually exclusive, inclusive, independent. A, it's a probability of A and B is, probability of A or B is. So they are dealing with this thing. When I just know the master formula, and once you know the master formula, you know what to do with it. You'll never go wrong. All the probability events are here. The probability event of being A or B, it is given as a statement or is given on the statement. Probability of A and B, you take the probability of A that you have and of B that you have, you multiply one another. Probability of A, it is given when the event occurs, and of B also is given when the other event occurs. So these two, be careful. The one I'm highlighting with red, with blue now. Be careful. They will give you on the statement. There's no way you can, where's the blue? blue. This ones, they will give you on the statement. This ones, in most cases. So what you can extract or find is probability of B, probability of event A. And here we are. The last one. The exhaustive event. What do we mean? This is when all the events of the sample space are used. Then the probability of A or of B is equals to 1. So what do they mean? It means that the whole equation now is equals to 1. That's what they mean. They mean the whole equation now is equals to 1. The whole equation, this whole thing, is equals to 1. So where is 1? 1 is here. We will rewrite this probability of A or B. This that are in the brackets. Now they become 1. When you add them, they are giving us 1. It's exhaustive. The last one. Complementary events are the events that are mutually exclusive and exhaustive at the same time. So Naling, probability of A plus probability of B, they give us 1. This is the normal probability that we know if there are 2 events. The red ball that are 5 and the blue balls that are red. So that are 3. So we will have 5 over 8 plus 3 over 8. They give us 1. This is what they talk about here. And remember, all of these formulas are derived from the original formula. This is the original formula, my people. Please don't sleep. This is where the marks comes from. Simple things. This is the original formula.